One can of Budweiser, one human body, one extraordinary story. It begins with a sound, the sharp crack of a pull tab, the satisfied hiss of escaping CO2, and then the cool rush of golden liquid meeting lips. This is Budweiser, 5% alcohol by volume, born from barley malt, hops, rice, yeast, and water. It is a modest drink. But what happens next inside the body that receives it is anything but modest. The tongue fires first. Thousands of taste receptor papillae ignite across its surface. Bitterness from the hops blooms at the back. Sweetness from the malt sugars tingles at the tip. The salivary glands receive their orders immediately. The parotid, submandibular, and sublingual glands open their ducts, flooding the mouth with amylase-rich saliva to begin breaking down the beer's residual carbohydrates even before swallowing. CO2 bubbles burst against the mucosal lining, releasing aromatic hop compounds upward into the nasal passage. This is why beer smells as much as it tastes, and already quietly, the ethanol has begun slipping through the thin oral mucosa directly into the bloodstream. No transporter protein needed, no invitation required. Ethanol is lipophilic. It dissolves through cell membranes the way smoke drifts through a window screen. The journey has begun. The epiglottis snaps shut over the airway. The pharyngeal constrictors contract in perfect sequence, squeezing the bolus downward. The esophagus carries it through the chest, past the heart, past the diaphragm, in a matter of seconds. The lower esophageal sphincter relaxes, and the beer enters the stomach. The stomach is magnificent in action. Its rugae folds smooth out as the liquid fills the lumen, and its gastric glands spring to life. Parietal cells begin pumping hydrochloric acid. Millions of molecular proton pumps firing simultaneously, dropping the gastric pH toward 2. Chief cells release pepsinogen, which the acid instantly converts to pepsin, a protease that attacks the barley malt proteins in the beer, shredding their long chains into smaller peptide fragments. 3 layers of stomach muscle, oblique, circular, and longitudinal, churn the contents into a homogeneous fluid called chyme, violently mixing beer with acid and enzyme in rhythmic peristaltic waves. And throughout all of this churning, the ethanol pours through the gastric mucosa into the portal blood. The stomach is the primary site of alcohol absorption. On an empty stomach, it happens fast. Within 20 minutes of that first sip, ethanol is reaching the brain. The pyloric sphincter opens in controlled pulses, releasing chyme into the duodenum. The body responds with precision. Cholecystokinin hormones trigger the pancreas to release its full enzymatic arsenal. Amylase for carbohydrates, lipase for fats, trypsin and chymotrypsin for proteins. The gallbladder contracts, pouring bile salts into the duodenum to emulsify trace lipid droplets from the hop oils into microscopic micelles that lipase can digest. By the jejunum, the long middle section of the small intestine, the beer has been chemically dismantled into its smallest components. The jejunum's interior is a masterpiece of biological engineering. Circular folds covered in millions of villi, each villus carpeted in microvilli, expanding the absorptive surface to the size of a tennis court folded into a tube less than an inch wide. Glucose enters through sodium-coupled SGLT1 transporters. Amino acids flow through their own channel families. B vitamins and minerals cross through specific transporter proteins. Fatty acid micelles diffuse passively through the enterocyte membranes, are reassembled into triglycerides, packaged into chylomicrons, and sent into the lymphatic system. Ethanol, needing nothing, floods through everything, absorbing across the entire intestinal surface so rapidly and completely that by the time the jejunum finishes its work, essentially all the alcohol from that one can is in the bloodstream. The portal vein arrives at the liver's gate carrying everything the intestines have absorbed: glucose, amino acids, vitamins, minerals, and a significant ethanol load. The liver receives this blood before any other organ. This is not an accident. The liver is the body's great chemical refinery, and ethanol is one of its most demanding clients. Inside the liver's sinusoids, microscopic channels lined with hepatocytes, the work begins. Glucose is converted to glycogen for storage. Amino acids are sorted and processed, and alcohol dehydrogenase, a zinc-containing enzyme in the hepatocyte cytoplasm, seizes the ethanol molecules and oxidizes them to acetaldehyde, a toxic intermediate more dangerous than ethanol itself. Aldehyde dehydrogenase in the mitochondria immediately converts acetaldehyde to the safer acetate, which enters the Krebs cycle or is exported to peripheral tissues. When ethanol concentrations are high, a second pathway activates. CYP2E1, part of the cytochrome P450 system in the smooth endoplasmic reticulum. This pathway is less efficient and generates reactive oxygen species as a byproduct. Chemical radicals that attack proteins, lipids, and DNA. From a single beer, the liver handles its ethanol load with practiced competence, processing approximately 1 standard drink per hour. But the pathway exists, and with chronic excess, the damage accumulates. Ethanol crosses the blood-brain barrier effortlessly. The tight, junction-sealed endothelial wall that excludes most drugs and toxins from the brain offers no resistance to alcohol's lipophilic passage. Within 30 minutes of drinking, ethanol concentrations in the brain mirror those in the blood. At GABA receptors, the brain's primary inhibitory channels, ethanol acts as an amplifier, keeping the chloride channel open longer, flooding neurons with negative charge, reducing their excitability. Muscles relax. Anxiety softens. The relentless inner monologue quiets. At NMDA receptors, ethanol acts as a blocker, reducing calcium influx and blunting the molecular machinery of memory formation. This is why details blur with enough drinks. Deep in the ventral tegmental area, ethanol suppresses the GABAergic interneurons that normally restrain the dopamine reward neurons. Released from inhibition, those neurons fire, sending dopamine surging down the mesolimbic pathway to the nucleus accumbens. This is the neurological signature of pleasure. This is why, after a long and difficult day, that first cold Budweiser feels, in the most biological sense possible, like relief. In the cerebellum Purkinje cells, the elegant branching neurons that coordinate balance and fine motor control begin to falter in their rhythmic firing. The world tilts slightly at its edges. In the hypothalamus, antidiuretic hormone secretion is suppressed, a decision the kidneys will act on shortly. The heart receives the ethanol-carrying blood through the coronary arteries. Ethanol stimulates endothelial cells throughout the vascular system to synthesize nitric oxide, causing smooth muscle relaxation and vasodilation. The warm flush spreading across the skin, the reddening of the cheeks, the paradoxical feeling of warmth while the body's core temperature remains stable. Blood pressure shifts subtly as peripheral vascular resistance falls. In skeletal muscle, the glucose and amino acids from the barley are put to work, feeding glycolysis, replenishing glycogen stores, fueling ATP production in the mitochondria. But ethanol casts a shadow here. It suppresses the mTOR signaling pathway governing muscle protein synthesis, and its metabolite acetaldehyde disrupts mitochondrial function. Athletes who drink after training know the consequences without knowing the mechanism. Slower recovery, blunted gains, persistent soreness. Meanwhile, deep in the colon, the gut microbiome encounters the residual unabsorbed Budweiser components. Hop alpha acids with their mild antimicrobial properties, barley fiber fragments that beneficial bacteria ferment into short-chain fatty acids, and trace ethanol. Even at the concentrations present after a single beer, ethanol selectively suppresses lactobacillus and bifidobacterium populations. The tight junctions of the intestinal epithelium loosen slightly. A small amount of bacterial endotoxin, LPS, may leak through the barrier into the portal blood, where the liver's Kupffer cells stand ready to intercept it. From one can, the effect is transient. The microbiome recovers, but the pathway is real. The hypothalamus' decision to suppress antidiuretic hormone has now reached its consequence. In the kidney collecting ducts, without ADH driving aquaporin 2 water channels to the apical membrane, water that would normally be reabsorbed escapes into the urine. The body excretes more water than it takes in from the beer itself, a net fluid loss that contributes to the dry mouth and headache of the morning after. In the glomeruli, the kidney's microscopic filtration units, blood plasma is pushed through a specialized basement membrane and podocyte filtration slits, creating a river of primary filtrate. Ethanol metabolites, acetate fragments, hop acid byproducts, and processed waste compounds all pass freely into the filtrate. The proximal tubule reabsorbs the useful components. The loop of Henle and distal tubule fine-tune the electrolyte balance. And the collecting duct releases the dilute, waste-carrying urine into the renal pelvis, down the ureter, and toward the waiting bladder. The body completes its accounting. The bladder fills, the urge arrives, and one more time, the extraordinary, largely invisible machinery of human physiology performs its quiet miracle. By morning, the ethanol is entirely gone. The liver has metabolized every molecule, the last acetaldehyde long since converted, the last natrioxidized. Blood alcohol has returned to zero, but the brain, which spent the evening adapting to ethanol's presence by upregulating its glutamate receptors and downregulating its GABA responses, now faces a brief neurological rebound. Without ethanol to suppress the newly sensitized excitatory system, there is a burst of neural hyperexcitability, registered as headache, sensitivity to light and sound, the dull irritability of a hangover morning. It passes. The colon finishes processing the residual fiber. The kidneys clear the last metabolic waste. The liver replenishes its glycogen, the microbiome rebalances, the tight junctions recover. The body does what it always does. It adapts, compensates, restores, and moves on. 1 can of Budweiser, 5% alcohol, 12 fluid ounces, 145 calories, has passed through 16 organ systems, touched hundreds of biochemical pathways, interacted with thousands of molecular machines, and been completely metabolized into carbon dioxide, water, and heat. From first sip to final excretion, the entire journey takes roughly 12 hours. The body asks nothing in return except that you treat it, every once in a while, with the respect that such extraordinary complexity deserves. The golden journey is complete. A note on the science. This story follows the actual biochemical and physiological journey of Budweiser beer through the human body, drawing on established principles of gastroenterology, hepatology, neuroscience, nephrology, and nutritional biochemistry. It is intended as an accessible educational narrative, not medical advice. Moderate alcohol consumption is defined as up to 1 standard drink per day for women and up to 2 for men. Must be 21 or older to consume alcohol in the United States. Please drink responsibly. Like and share this video to your friend and subscribe my channel. Thank you. Take care, my friend.